Hello and welcome to my video on Simple Harmonic Motion. So first of all, what is Simple Harmonic Motion? And we're also going to be talking about frequency and period, and a couple other definitions. So Simple Harmonic Motion is a motion that is created when something oscillates back and forth. Basically, it goes from a beginning state to a middle state and then back to the beginning state. It always ends up at the same place that it started, wherever you look at throughout the cycle. And it's oscillating across an equilibrium point. Well, what is an equilibrium point? It's the center of the motion. It is when the forces are balanced, and it is the state that the object or wave wants to revert back to. So we can talk about two different main types of simple harmonic motion in this course. The two main ones are, the two mechanical main ones are pendulums. And so pendulums swing back and forth, and then they come back the same direction that they left. If you're talking about a pendulum, the middle point, the point down here, that is the equilibrium point. So at any given moment, it wants to pull itself back to that equilibrium point. And that's what causes this simple harmonic motion. Same thing with the spring. So a spring, let's see, a suspended spring. It could be a horizontal spring or a suspended spring with a mass. Okay, this spring, if it's compressed, then it wants to push out. Okay, if it is extended, then it wants to pull up. And so it's always wanting to go back to this equilibrium point. So it always wants to go back to this equilibrium point. Okay, same sort of idea as with the pendulum. So what is, there's a couple other words here. What is the period? A period is the time it takes to do one cycle from start to end, but it has to be start and end in the same position. So the common mistake here is to do half of the period in a given situation. So for a pendulum, it's not going from here to here. It's actually going from here to here and then back. That's the key. It has to end up at the same place that it started, in the same position that it started. Frequency is the cycles per second, so it's 1 over seconds. It's measured in hertz. It's also 1 over period, and we'll talk more about that in a moment. Amplitude is the difference between the maximum and the equilibrium point. So, for example, with the pendulum, or the amplitude is the difference between this point and this point, whatever we're talking about here. Maybe it's height, or maybe it's a angled distance, or whatever. I don't know. And then it's more easy to see with a spring. So if it's stretched one way, that would be the amplitude. If it's stretched the other way, that would be the amplitude, whatever it is. Okay. Pendulum springs are both simple harmonic motion, but also waves, and a whole ton of different waves: sound waves, EMR, electromagnetic radiation, as well as mechanical waves like ocean waves or whatever. So a whole bunch of different waves. There are a bunch of different things that are simple harmonic motion. Anything with a frequency ends up having simple harmonic motion. Okay, so anything that's repeating, going back to the same place that it did before. If it has a cycle, you can think about that, right? So, yeah, those are all simple harmonic motion. It's trying to get back to the equilibrium point. Okay, so the formula that we have to know about is T equals 1 over F, which is period, which is seconds, equals 1 over frequency, which is in hertz. But we can actually go a little bit further, just unit cancellation, to see that it's actually 1 over, and hertz is 1 over seconds. So 1 over seconds is just seconds, and that's why it's all equal. Okay, let's use that formula in the following example question. If the pistons in a car's combustion engine complete 3,000 rotations every minute, so 3,000 RPM, determine the period of the piston's motion. So there's a few things to do, but what you have to recognize is this is rotations every minute. So actually, I think what I'm going to say is let's solve this the other way around. Why don't we solve the frequency first? Yeah, we're going to solve the frequency first. So if you want to try this question out, I would recommend pausing the video here and seeing if you can get the same answer that I do. All right, so first of all, frequency is measured in hertz. So frequency is in hertz. Hertz is another way of saying 1 over seconds. And in different questions, this will be different, but it's either 1 cycle per second, or per however many seconds, or it'll be, 1,000 cycles per second, and so it'll depend. Or you could use rotations, or whatever you're talking about, right? So with that in mind, we know frequency is 1 over seconds. So if we take the minute and we call it 60 seconds, and we make it over 60 seconds, and we say it's 3,000 rotations per second, then we can actually simplify that to 300 over 6, and this can divide by 6, so 50. Yeah, 50 hertz would be our final answer. Okay, the nice thing about getting this value, we could go the other way around, but the nice thing about getting this value is period equals, and we'll use a different color for that, period equals 1 over frequency, as we've already said, so it's 1 over 50 hertz, which is going to be 0.02 seconds, I believe. Let's actually just try that in the calculator so I don't make a mistake. 1 divided by 50, there it is. Alright, so that would be our final answer, although we should probably double check sig digs. I mean, every minute it seems like it's a precise calculation, so 4 sig digs, so I guess this is probably not ideal, but let's change this to 4 sig digs. 1, 2, 3, 4 times 10 to the negative 2 seconds. So probably should have better sig digs in the question, but that's alright. And same thing with this one, we should probably have better sig digs, but that's alright. Alright, let's try another question, basically the same sort of idea, but now instead of car engine, we're talking about a Blu-ray disc that spins. So go ahead, try this out, pause the video, and see if you get the same answer I do. Alright, so let's go ahead and try this out. The frequency of rotation of the base Blu-ray disc in units of hertz. So again, we're looking for the frequency, so frequency is 1 over seconds, so it's the number of cycles per second. So this is rotations per minute, so it's 60 seconds. So this is 81 over 6, which we can divide by 3 top and bottom. Which is 27. And that would be 13.5 hertz. And we have 3 sig digs, so that would actually be perfectly fine to leave our answer there. Okay, I would probably just recommend, just typing it in your calculator. Don't bother simplifying it like I do. It's just a little bit of mental math here if you want to test your mental math skills. Again, pause the video and see if you get the same answer I do. But at this point, this is the nice thing about simplifying, is we can just put in that value, which means it can actually be 2 over 27. So it's a more precise answer, although, you know, we still have to plug that into the calculator. So 0.074. And I believe that just keeps repeating like that. Yep. So let's do with sig digs. 74.0 times 10 to the -2 seconds as our final answer. Alright, so I hope this video helps you better understand simple harmonic motion, what it is, and especially some calculations for frequency and period. Good luck!